Hello and welcome to the AI Research Roundup. I'm your host, Alex. Today is May 8th, 2025. We're looking at an ICLR conference paper, BERD, a Trustworthy Bayesian Inference Framework for Large Language Models, published just over 3 months ago. This paper introduces BERD, a system helping large language models make more reliable probability estimates, really important when dealing with incomplete information. It cleverly combines the language model's knack for understanding context with a Bayesian network. That's a type of model for reasoning with uncertainty. This process involves the LLM first identifying key factors for a situation, what the paper calls abduction, and then using those factors to deduce the final probabilities. Alright, so this figure really illustrates the practical difference BERD makes in what are called mission-critical tasks. We see a scenario, choosing locations for electric vehicle charging stations. An OpenAI large language model, when asked, gives pretty coarse confidence scores, like 90% for 2 different locations, and ultimately can't decide. But BERD, it provides much more specific probabilities for each option, like 86.2% for one and 74.3% for another, allowing it to make a clear, informed recommendation. This really drives home how BERD's structured approach leads to more trustworthy outcomes. Alright, building on that electric vehicle charging station example, this next figure gives us a look under the hood at how BERD actually works. It shows the system using abduction, where the large language model identifies key factors from the scenario, like local demand. Next, it estimates a conditional probability table, or CAPTAIN, a lookup table of outcome likelihoods for factor combinations. Then, using large language model entailment to connect the current situation to these factors, it deduces the final probability through marginalizing, essentially combining probabilities across all factors. The diagram also hints at BERD's ability to generate useful follow-up questions. Okay, so this table really quantifies BERD's improved reliability. It presents a preference-based, pairwise evaluation using the F1 score, which is a measure of a model's accuracy in these judgment tasks. We see BERD, particularly when combined with llama models, achieving, quote, average F1, scores around 0.59. This is substantially higher than other large language models using methods like chain of thought or COT. That's a technique where models attempt to reason step by step. For instance, GPT-4 COT scores closer to 0.29 here. The table also details results from ablation studies, experiments testing different BERD components, confirming its overall design is effective. Okay, so moving to actual decision-making performance. This next table shows how BERD stacks up against baselines on several decision-making benchmarks. These are essentially standardized tests for how well models make choices. We see datasets like Today, Plasma, and Common 2 Cents. The BERD underscore optimized version, which is their final model, when paired with Llama 3.1, achieves an accuracy of 74.3% on the Today benchmark, compared to 72.6% for the chain of thought approach. Similar improvements are seen across other datasets, and the other BERD columns represent ablation baselines, simpler versions used to confirm the design choices. So following on from those overall performance numbers, this table presents an ablation study. That's an experiment where researchers test individual components of their system. Here, it's looking specifically at factor generation methods, how BERD identifies the important pieces of information for a problem. It compares a direct method to BERD's abduction technique. Across all datasets, like Today and Plasma, and with both llama models, BERD's abduction consistently leads to higher performance scores and significantly fewer unknown instances. This highlights the effectiveness of BERD's abductive reasoning within its framework. So after seeing how important BERD's abductive reasoning is, this next table dives into another crucial aspect for the Llama 3.1 version, its loss functions. Loss functions. These are mathematical tools that help the model learn by measuring how far off its predictions are from the correct answer. The table compares the full BERD system against versions where either the Mr. loss or the MSE loss is removed across datasets like Today, Plasma, and C2S. In all cases, the complete BERD model performs substantially better. For example, scoring 74.3 on Today versus around 65 if one of those loss components is missing. Alright, so it's clear those specific loss functions are vital to BERD's overall strength. Essentially, this work presents BERD, a framework making large language models more trustworthy for estimating probabilities. It cleverly combines their knack for generating relevant factors, that's abduction, with a structured Bayesian network which maps how factors influence outcomes. The key takeaways are BERD's much more reliable probability estimates, leading to better decision-making, and its potential for training other models and asking smarter questions. That's our roundup for today. Thanks for joining.